Somewhere in the darkness between the stars right now, tonight, there may be two planets that once belonged to us. Not asteroids, not comets. Two worlds the size of Neptune, born from the same cloud that made the Earth, warmed by the same young sun, and then thrown out of the solar system forever. For 4 billion years they have been drifting, cold and dark and alone, and we are only now finding the evidence that they were ever here. It is written in a planet knocked onto its side, in a moon that looks stitched together from wreckage, and in the strange fact that when we try to rebuild our own solar system on a computer, it refuses to work unless we begin with more planets than we have and throw the extras away. The tidy diagram you were shown as a child is hiding something, and the further back you look, the worse it gets. Get comfortable and settle in. Hit subscribe if you're new here, because by the end of this, the calm night sky above you will never feel quite as permanent again. Now let's slowly ease into this. Part 1. The diagram and the doorway. Picture the drawing you were shown as a child. There is a small yellow sun in the corner, and then a set of tidy rings spreading outward, one planet resting on each ring like a bead on a wire. Mercury, then Venus, then Earth with its little moon, then rusty Mars. A gap, and then the giants, banded Jupiter, ringed Saturn, pale Uranus, storm blue Neptune. Everything is spaced out neatly. Everything is moving in calm, patient circles. Nothing is touching anything else. It is one of the first pictures of the wider universe that most of us ever hold in our minds, and it carries a quiet promise inside it. The promise is that this is how things are, and how they have always been, and how they will stay. Tonight I want to gently take that picture apart. Not because it is wrong exactly, but because it is a snapshot. It is a single frozen frame pulled from the end of a story that was far longer, far stranger, and far more violent than the drawing lets on. The tidy rings are real. The calm is real, at least for now. But the calm is the calm that comes after something, not before it. And the further back you follow the history of these worlds, the less the drawing looks like a plan that was carefully followed, and the more it looks like the aftermath of something that barely held together. Here is the fact that pulled me into this. In the year 2026, a study was published in the scientific journal Icarus that added new weight to an idea physicists have circled for years. The idea is this: our solar system may once have had more giant planets than it has today, not 4 giants, but 5, and possibly 6. And somewhere in the first few 100 million years of its life, it lost them. 2 worlds, roughly the size of Uranus or Neptune, may have been thrown out of the family entirely, flung into the darkness between the stars, never to return. Let me say that again slowly, because it is easy to let it slide past. We are not talking about a small icy rock. We are not talking about a comet or a stray asteroid. We are talking about entire planets, worlds large enough to hold oceans of gas and ice, worlds that formed in the same disk that made the Earth, out of the same material, warmed by the same young sun, and they are gone. They were here, and then they were not, and the solar system rearranged itself around the wound they left behind. Who hasn't misplaced their keys, or a phone, or a favourite pen? Losing a planet feels like it should belong to a different category of mistake. And yet the evidence that it happened is not a wild guess. It is written into the sky above you right now, in the tilt of a planet, in the shattered face of a moon, and in the stubborn refusal of our best computer simulations to build a solar system that looks like ours, unless we hand them extra planets to throw away. The study I mentioned focused on one very specific piece of that evidence. It looked at the moons of Uranus and the moons of Jupiter, and it asked a simple question. If the early solar system really went through the kind of violent instability the models suggest, could those moon systems have survived it intact? The answer the researchers found was sobering. The chance that the moon systems of both Jupiter and Uranus came through that chaos unharmed was low, less than 15%. In most of their reconstructions, the moons did not simply ride out the storm. When a wandering giant planet came close to Uranus, its gravity almost guaranteed that Uranus's original moons would be torn apart. And they were not thrown cleanly away. They collided with one another at tremendous speed, grinding themselves into a field of icy rubble that slowly, over long ages, gathered itself back together into new moons. That is the doorway. That is where we step through. Because once you accept that a planet in the drawing could be knocked sideways, that its moons could be smashed and rebuilt from debris, that two of its siblings could be exiled into permanent night, the neat rings stop looking like a diagram of the order. They start looking like the last survivors of something, and the question that follows is the one that will carry us through everything that comes next. What actually happened here? What did the calm sky above us have to live through to become calm? And how close did that violence come to erasing the small blue world we happen to be standing on? I should be honest with you from the start, in the spirit this channel always tries to keep. Almost everything we're going to talk about tonight is reconstructed from indirect evidence. Nobody watched the early solar system tear itself apart. There were no witnesses, no cameras, no records. Every clue we have is a clue we read backward, from the present into the past, the way a detective reads a room that has been quiet for 4 billion years. That means we will move carefully. We will separate what is measured from what is modelled, and what is modelled from what is merely imagined. But even with all that caution, the picture that emerges is genuinely unsettling. Not because there is a monster in the dark. Because the order we take for granted turns out to be far thinner, far younger, and far more accidental than the drawing ever suggested. So settle in, and let the tidy rings hang in your mind for one more moment. Hold on to that calm, and then let us begin, very slowly, to follow the history of these worlds backward, one layer at a time, into a past that gets stranger and more violent the further back we look. The diagram you are shown is where we start. It is not where the story starts. Let me linger for a moment on just how radical the idea of a lost planet really is, because familiarity can make even astonishing claims sound ordinary. When I say the solar system may have lost a planet, your mind might quietly file it alongside a demoted Pluto, some technicality about definitions and categories. It is nothing of the kind. An ice giant is a world in the same class as Uranus or Neptune, a body many times the mass of the Earth, wrapped in an atmosphere thousands of miles thick, quite possibly ringed, quite possibly attended by its own moons. If one of these had stayed, it would be up there tonight as a 5th or 6th giant, a full member of the family, with a name we all learned in school. Instead, it is gone, and the space where it might have been holds nothing but the faint memory of its passage, encoded in the orbits of the planets that outlived it. There is something almost vertiginous about that, and I want you to feel it before we go any further, because it sets the tone for everything to come. We tend to assume that the objects in the sky are permanent, that the cast of characters was fixed long ago and will not change. The sun rises, the planets wheel through the constellations, the moon runs through its phases, and it all feels eternal. But permanence, on the scale we are about to explore, is an illusion produced by the shortness of a human life. Stretch your view across billions of years and the solar system stops looking like a finished stage set and starts looking like the wreckage of a demolition that happened to leave a few rooms standing. Tonight we're going to walk through those rooms, and then we're going to walk down into the rubble beneath them. I promise the journey will be gentle even where the subject is not. This is the kind of story that is best received slowly, with your eyes closed if you like, letting each idea settle before the next arrives. There is no rush. The events we are discussing took hundreds of millions of years to unfold, and we can afford to take our time following them. So keep the tidy drawing in your mind, the neat rings and the calm circles, and let it be the last comfortable thing you hold before we begin taking the comfort apart. You may be wondering why a discovery about the ancient past would land as terrifying rather than merely interesting, and it is a fair thing to wonder before we commit 2 hours to it. The answer is that this story quietly removes a flaw you did not know you were standing on. Most of us carry an unspoken assumption that the arrangement of the heavens is the stable backdrop against which everything else happens, the one thing that does not change. The Earth may have its upheavals, empires may rise and fall, but the planets, we assume, simply are, fixed and permanent. What tonight takes apart is exactly that assumption. It shows the backdrop itself to have a violent history, to have gained and lost members, to have been rearranged by catastrophe. And once the backdrop is revealed to be a survivor rather than a fixture, a subtle unease settles in that no single frightening fact could produce. It is the unease of learning that the most permanent-seeming thing you know is itself a temporary arrangement. Part 2. How to read a crime scene 4 billion years cold. Before we go back in time, we need to talk about how anyone can claim to know what happened 4 billion years ago in the first place. It is a fair question, And if you have ever felt a flicker of doubt when a scientist describes the ancient past with confidence, that instinct is worth respecting. We did not see it happen. So how do we know anything at all? The answer is that the past leaves marks, and the marks do not fully heal. A river that dried up long ago still leaves its winding channel carved into the rock. A forest that burned still shows the scar in the rings of the trees that survived. And a solar system that went through violence still carries the evidence in the arrangement of its worlds, in the angles of their spins, in the surfaces of their moons, and in the strange gaps and clusters of debris that orbit far from the sun. We do not have a recording. We have a room full of scars, and the work of science is to stand in that room and ask what could possibly have left each one. This is the honest core of the whole subject, so I want to sit with it for a moment. When physicists say the early solar system probably had extra planets, they are not reading it from an ancient text. They are doing something more like reverse engineering. They take everything we can actually measure today, the orbits, the tilts, the craters, the way the debris is distributed, and they run the clock backward in a computer, over and over, trying to find a starting arrangement that naturally produces the ending we see. And what they keep finding is that the ending only falls out cleanly if the beginning had more pieces than the ending does. Some of those pieces have to be removed along the way for the math to work. That is where the lost planets come from. They are not seen, they are required. Now, you should hold a healthy grain of doubt about any story built this way, and the scientists who build these models hold that doubt too. All of the evidence we can ever have about the distant past of the solar system is indirect. We are patching together what happened from what remains, and different starting points can sometimes lead to similar endings, which means more than one story can fit the same scars. This is not a weakness anyone hides. It is the honest condition of the whole field. But indirect does not mean baseless. When several completely different kinds of evidence all point the same direction, the case gets strong even without an eyewitness. And in this case, several completely different kinds of evidence do point the same direction. Let me give you the first and most obvious scar, the one that started serious people wondering whether something dramatic had happened out there. That scar is a planet. It is Uranus. And the thing wrong with Uranus is the way it turns. Every major planet in the solar system spins. That is normal. They inherited their spin from the swirling disk they formed in, and so they mostly spin in roughly the same upright direction, like tops standing more or less straight on a table. Earth leans a little, about 23 degrees, which is why we have seasons, but it is still essentially standing up as it goes around the sun. Uranus does not stand up. Uranus lies down. Its axis is tipped by about 98 degrees, which means it is knocked over completely, rolling around the sun on its side rather than spinning upright. Its poles take turns pointing almost straight at the sun. For part of its long year, one entire hemisphere bakes in continuous daylight while the other sits in continuous darkness, each lasting decades. Here is why that matters so much. A tilt like that does not happen on its own. Nothing in the gentle, ordinary process of building a planet from a spinning disk tips a world all the way onto its side. The disk spins one way, the planet forms spinning the same way, and it should end up upright. To knock a planet as large as Uranus over by 98 degrees, you need violence. You need either a colossal impact, a collision with another large body, or an extremely close and powerful gravitational encounter with something big enough to wrench the whole planet around. Either way, the tilt is a fingerprint. It is physical proof, still visible today, that Uranus lived through something catastrophic. The planet is lying down because something knocked it down, and once you notice one scar, you start looking for others, and you find them. You find them in the moons that circle Uranus, because those moons orbit around the tipped-over equator, as if whatever tilted the planet also rearranged its entire family of moons at the same time. You find them in the surfaces of some of those moons, which look far more battered and reworked than a quiet history would allow. You find them in the way the giant planets sit today, in orbits that the simulations say are too tidy, too settled, to have formed exactly where they are without something shoving them into place. Each of these is a scar. Individually, each one might have another explanation. Together, they start to describe a single event. So this is the tool we will carry with us for the rest of the night. We are going to treat the solar system as a scene that has been silent for 4 billion years, and we are going to read the scars one by one. We will start at the calm surface, the drawing, the tidy rings, and then we will follow the marks downward and backward into older and stranger layers of the past. And I want to warn you, kindly, before we go any further. The scars get worse the further back we read them. The calm sky above you is the top layer, the finished surface. Underneath it, the history only becomes more violent. The scars are still here. We just have to learn to see them. It helps to see that reading the past from present scars is not something scientists do only for the solar system's lost planets. It is the ordinary method of nearly every historical science, and it works. Consider a few other scars we read the same way. Venus spins backward, slowly, in the opposite direction to nearly everything else, and that too points to some ancient violence, a collision, or a strange gravitational history that flipped or braked its rotation. The Earth has a moon far larger, relative to its planet, than almost any other in the solar system, and the best explanation is that a body the size of Mars struck the young Earth a glancing blow, and the debris flung into orbit gathered into the moon. We did not witness any of these events. We infer them from what remains, from the spin of a planet and the chemistry of moon rocks, and the inferences are strong enough that few serious people doubt them. So when we turn the same method on the lost planets, we are not doing anything exotic. We are applying the standard tools of the historical sciences to the oldest crime scene we can reach, and the tools have a particular character worth understanding. They do not deliver certainty. They deliver the best explanation, the story that accounts for the most scars with the fewest assumptions, always open to revision if a new scar turns up that the story cannot fit. That is how you should hold everything I tell you tonight, not as a decree from on high, but as the leading reconstruction, the account that currently fits the evidence best, offered with the honesty that it might yet be refined. I dwell on this because the temptation, with a subject this dramatic, is to slide from what we know into what we merely imagine without marking the border. This channel tries never to do that. When we are on solid ground, measured, observed, repeatedly confirmed, I will tell you. When we are on the softer ground of models and reconstructions, I will tell you that too. And when we cross into outright speculation, the wondering that goes beyond the evidence, I will mark it clearly, because the speculation is only enjoyable if you know that is what it is. The scars are real, the reading of them is careful, and the border between the two is something I will keep visible the whole way down. There is a further reason this careful scar-reading approach matters for tonight in particular, and it has to do with how the finding reached the wider world. A study like the one that opened this video does not arrive as a photograph of two planets leaving. It arrives as a careful argument, a chain of reasoning that runs from the tilt of a planet and the state of its moons, through models of what a close encounter would do, to a conclusion about what the early solar system most likely contained. Somewhere along the way, as the finding is retold and simplified, the careful hedges tend to fall off, and a measured claim about one or two probable extra giants can harden into a flat headline that we lost exactly 2 planets. I want to keep the hedges on. The honest version is more interesting than the headline anyway, because the uncertainty is part of the wonder. We are reconstructing the unrecoverable, and doing it well enough to argue about the details, and that is a genuinely astonishing thing for a species to be able to do at all. Part 3. The Violent Birth. To understand how a solar system could lose 2 planets, we have to go all the way back to the moment it had none. We have to go back before the Earth, before the Sun, before there was any warmth or light out here at all, to a cold, dark cloud drifting in the arm of a galaxy. That cloud is where everything you have ever seen or touched or loved was waiting, not yet assembled, spread thin across a stretch of space so large that light itself would take years to cross it. The cloud was made mostly of hydrogen, the simplest and oldest ingredient in the universe, with a little helium and a faint dusting of heavier elements, the ash of stars that had already lived and died before our sun existed. It was thin, and it was cold, only a few degrees above the coldest temperature that is physically possible. For a very long time, perhaps millions of years, it simply drifted in no hurry, held in a loose balance between its own faint gravity pulling inward and its own gentle pressure holding outward. Left alone, it might have drifted like that forever. But something disturbed it. Perhaps the shockwave from a nearby exploding star rolled through and squeezed it. Perhaps it simply drifted through a denser region, and the balance tipped. However it began, one part of the cloud grew slightly denser than the rest, and its gravity grew slightly stronger, and it began to pull the surrounding material inward toward itself. And once that began, it did not stop. I want you to slow down here and be inside this, because it is one of the most extraordinary events in the whole story, and it is easy to reduce it to a single dry sentence. So let it unfold in front of you. Imagine you are floating in the middle of that cloud as it begins to fall together. At first, almost nothing seems to happen. The darkness is nearly total, the cold is absolute, and the motion is so slow it is imperceptible. But over thousands of years, the space around you very gradually thickens. The faint haze grows denser, then murkier, then genuinely dark, as more and more matter crowds inward toward a center you cannot yet see. The cloud, which had been barely turning, begins to spin faster as it shrinks, the way a spinning skater pulls in their arms and speeds up. The spin flattens the collapsing material, so that the shapeless cloud becomes a slowly whirling disk, wide and flat, with a growing bulge of matter piling up in the middle, and that central bulge is getting hotter. Pressure builds as more mass falls in. The temperature climbs, from frigid to merely cold, from cold to warm, from warm to hot, and then hotter still, past anything you can imagine, until at the very center of the whirlpool the conditions cross a threshold. The hydrogen there is squeezed so tightly and heated so fiercely that its atoms begin to fuse together, and in that instant a new star ignites. Our sun switches on. The darkness you have been floating in for the whole slow age of collapse is suddenly flooded with light, and the disk around you glows for the first time under a sun that did not exist a moment before. That is the birth of our star, and I hope you can feel how little it resembles the calm yellow circle in the corner of the drawing. It was not placed there gently. It was compressed into existence out of a collapsing cloud, lit by the crushing of matter under gravity, a slow catastrophe that happened to produce something that gives light instead of taking it. And the leftover material, the wide flat disk still whirling around the newborn sun, is the stuff that every planet, including ours, would be built from. Roughly 99% of the collapsed cloud went into the sun itself. Everything else, every planet, every moon, every asteroid and comet, every atom of the ground beneath your feet, was made from the thin remainder, the scraps left spinning in the disk. Inside that disk, the building began. It started impossibly small. Tiny grains of dust, each far smaller than a speck you could see, drifted through the gas and occasionally bumped into one another and stuck. Those clumps grew into larger clumps, and the larger clumps had a little more gravity, and so they gathered material a little faster and grew faster still. Pebbles became boulders, boulders became mountains, mountains became bodies hundreds of miles across, large enough that their own gravity pulled them into spheres, and these are what we call planetesimals, the seeds of planets. They swept through the disk, colliding and merging and sometimes shattering, in a long chaotic demolition that gradually cleared the disk and concentrated its material into a smaller number of larger and larger worlds. None of this was orderly. It was a construction site with no supervisor, running on collision and chance. Bodies smashed together and fused, or smashed together and broke apart over and over for millions of years. The planets we know are the ones that won, the ones that grew big enough and swept up enough of their neighbours to dominate their own patch of the disk. But the process that built them was inherently violent, and it did not distribute its results evenly. Where you formed in the disk, how close to the sun or how far, decided everything about what you could become. And that division, the split between the warm inner disk and the cold outer disk, is the next scar we have to read. Because it is the reason the giants grew where they did, and the reason there were so many of them, and ultimately the reason 2 of them could be lost. The sun had switched on. The disk was turning, and out beyond a certain line in the cold, the largest and most dangerous worlds were about to begin taking shape. It is worth sitting with the sheer patience of that collapse, because the timescales are part of what makes it hard to picture. The cloud did not fall together in a dramatic rush. From the moment the balance tipped to the moment fusion ignited at the centre, something like 100,000 years may have passed, and the disk itself lingered for millions of years after that. On a human clock these are unimaginable spans, but on the clock of the collapse they are almost sudden, a swift gathering of a structure that had drifted, unchanged for far longer. Everything about cosmic time works like this. The events that reshape worlds are quick compared to the ages of waiting that surround them, and the trick of understanding this story is to keep switching between the 2 clocks, the slow one and the fast one, without losing your footing. Notice, too, the detail that almost everything went into the sun. Roughly 99% of the collapsing cloud fell into the star at the centre, and every planet, every moon, every asteroid and comet, you, the chair you're sitting in, the air you're breathing, All of it was built from the last 1%, the thin scraps left turning in the disk. The solar system is, in a sense, the sun's leftovers, the crumbs from an overwhelmingly dominant central body, and those crumbs did not distribute themselves evenly or fairly. The disk had a structure, a gradient of temperature and density running from the scorched inner edge out to the frozen fringe, and where a world happened to form along that gradient decided everything it could ever become. The same batch of material, sorted by nothing but distance from the fire, produced both small dry rocks and giant balls of gas and ice. There is one more thing I want you to carry out of this beginning, because it will matter later. The process that built the planets was not tidy assembly. It was collision. Bodies grew by smashing into one another and sticking, and for every clean merger there were violent shattering blows, near misses, and bodies flung onto wild new paths by the gravity of their larger neighbours. Violence was not an interruption of planet formation. Violence was the method. The calm, well-separated worlds of the finished drawing were carved out of a chaos of impacts, and the chaos did not end when the planets reached their full size. It simply moved up a level, from colliding rocks to colliding worlds, and when worlds collide or come close, the consequences are the scars we came here to read. I want to add one more layer to the newborn disk, because it connects the grand story to something you can almost hold. Among the very first solid things to form in that disk were tiny glassy spheres, droplets of rock that were flash melted and then frozen again in the early chaos, and some of them survive to this day inside the oldest meteorites. When scientists slice open certain ancient meteorites, they find these little beads embedded in them, unchanged for 4.5 billion years, older than the Earth itself. Holding a meteorite like that is as close as anyone will ever come to touching the disk directly, to putting a hand on a piece of the actual material that was turning around the young sun before any planet existed. The grand collapse we have been imagining is not only inference and simulation. Pieces of its earliest moments are sitting in laboratories and museums right now, small enough to hold in your palm. Part 4. The Sorting of Worlds. The newborn sun did something to the disk around it that would decide the fate of every planet, including the two that would eventually be lost. It divided the disk into two realms, an inner realm and an outer realm, and it drew the border between them with heat. Close to the sun, the disk was hot. The young star poured out light and warmth, and near in that warmth was fierce enough that only the most stubborn materials could survive as solids. Rock could survive, metal could survive, but the lighter, more common substances, especially water, could not. Near the sun, water existed only as vapour, a gas that would not clump or freeze or gather into anything. So the inner disk had relatively little solid material to build with. It had rock and metal, and not much else. The worlds that formed there had to be assembled from that limited supply, and so they came out small. Mercury, Venus, Earth, and Mars are the children of the warm inner disk, 4 modest rocky planets, built from the only ingredients that could hold their shape so near the fire. Farther out, everything changed. Beyond a certain distance from the sun, the disk was cold enough that water could freeze into ice, and so could other substances like ammonia and methane. Scientists call that boundary the frost line, and crossing it is like stepping from a desert into a country buried in snow. Suddenly there was far more solid material available, because now the abundant water that was useless as vapour near the sun became abundant ice out in the cold. Worlds forming beyond the frost line had a much larger supply of building blocks, and so they could grow much faster and much larger than anything in the inner disk. And when a growing world out there reached a certain size, something remarkable happened. It became massive enough that its gravity could grab not just solids, but gas itself, the hydrogen and helium still filling the disk. Once a world could pull in gas, it could grow explosively, swelling into a giant. This is where the giants were born, and they are worth pausing on, because their scale is part of what makes their story land. Jupiter formed first and grew the largest, gathering an enormous envelope of gas around a heavy core. To give you a sense of it, if Jupiter were hollow, you could pour roughly 1,000 Earths inside it, and still have room to spare. It is not a planet in the sense that Earth is a planet. It is a failed second sun, a ball of gas so large that it dominates the outer solar system by sheer mass, more massive than all the other planets combined several times over. Saturn formed next, a little smaller, wrapped in the rings that make it the most beautiful object many of us ever see through a telescope. Saturn has a curious distinction that says something about how these worlds are built. Its average density is lower than the density of water. If you could find an ocean large enough, Saturn would float in it. That is how much of Saturn is gas, spread over so enormous a volume that the whole planet is, on average, lighter than the water in your kitchen tap. Then came the two outermost giants we still have, Uranus and Neptune. These formed farther out and more slowly, and here the timing mattered enormously. The gas in the disk did not last forever. The young sun's radiation and winds gradually blew the leftover gas away into space, and once the gas was gone, no planet could gather any more of it. Jupiter and Saturn had grown fast enough to seize huge amounts of gas before it vanished. Uranus and Neptune were too slow. They grew large, they gathered ices and some gas, but they missed the window to become true gas giants. So instead they became something a little different, worlds we call ice giants, made largely of water, ammonia and methane in strange, hot, dense forms, wrapped in thinner atmospheres of hydrogen and helium. They are the smaller cousins of Jupiter and Saturn, and it is worlds like these, ice giants, that our story is about to start losing. I want you to hold the whole arrangement in your mind for a moment, because this is the closest the early solar system ever came to matching the tidy drawing, and it is the calm before the real violence. Picture it. The sun burns at the centre. 4 small rocky worlds circle close in, warm and dense. Beyond the frost line in the cold, the giants turn slowly through the last of the fading gas, immense and stately. It looks, for a brief window, almost orderly, almost like the diagram. But there is a detail hidden in that picture that the drawing never shows you, and it is the detail that dooms the piece. The giants did not form spread comfortably apart the way they orbit today. They formed closer together. They were packed into a tighter region of the outer disk, crowded near one another, several massive worlds sharing a smaller stretch of space than they occupy now. And there may not have been 4 of them out there. There may have been 5. There may have been 6. Here is why that crowding is so dangerous, and it is a piece of physics you already understand from everyday life, even if you have never put it into words. Large masses pull on each other. The closer 2 heavy objects are, the harder they tug. When you have several giant planets packed near one another, each one is constantly pulling on all the others, and those pulls add up, and they interfere, and they build. A single planet orbiting a star alone can circle in perfect peace, essentially forever. But a crowd of giant planets, jostling one another with their gravity, is a fundamentally unstable arrangement. It is a system loaded with tension, like a stack of stones balanced a little too high, holding together only as long as nothing tips the balance. For a while, in the early solar system, the balance held. The giants turned in their crowded orbits, tugging on one another, the tension quietly building. But an arrangement like that does not stay balanced forever. Sooner or later, the pulls line up the wrong way, the tension releases, and the whole system lurches. That lurch is coming. It is the centre of everything we're here to talk about, the moment the tidy picture broke. But before we watch it happen, I have to show you the strangest piece of evidence of all, the reason we believe there were extra giants in that crowd in the first place. Because we did not find the lost planets by seeing them. We found them by trying to rebuild our own solar system on a computer and discovering again and again that it simply would not come out right unless we started with worlds that are no longer here. I want to give you a cleaner sense of why the frost line matters so much, because it is the hinge the whole story turns on. Imagine walking outward from the sun through the young disk carrying a thermometer. Near the sun the reading is brutal, hot enough that even rock is on the edge of vaporizing, and certainly far too hot for any ice to form. Keep walking outward, and the temperature falls steadily, until you cross a particular distance where it finally drops low enough that water can freeze. That line is the frost line, and crossing it changes the local supply of building material dramatically, because water is one of the most abundant substances in the universe. Inside the line, water is a useless vapor. Outside it, water is solid, and solid material is what planets are built from. So the outer disk was, in effect, far wealthier in building blocks than the inner disk, and wealth in building blocks means faster growth and larger worlds. This is why the giants live outside and the small rocky worlds live inside. It is not an accident of placement. It is a direct consequence of where the frost line fell, and it explains the timing that would later prove fatal. Because the giants had so much material to work with, they grew quickly, and the largest of them, Jupiter and Saturn, grew massive enough to seize gas before the disk's gas was blown away by the young sun. The gas did not last long, only a few million years, and that deadline sorted the giants into two kinds. The ones that grew fast enough to grab gas became the huge gas giants. The ones that grew almost as large but a little too slowly, missing the gas deadline, became the ice giants. And it is the ice giants, the near misses, the ones that were almost gas giants but not quite, that our solar system would later throw away. Hold that arrangement one more time and notice how crowded it was. In the finished drawing, the giants are spread comfortably across an enormous stretch of the outer solar system, each in its own wide lane. But that spacing is the end state, the result of the very instability we're building toward. When the giants first formed, they were packed into a far tighter region, several massive worlds crammed into a fraction of the space they now occupy, tugging on one another constantly. Picture it as a crowded room rather than a set of distant estates. Everyone is too close to everyone else, and every motion pulls on every other. A room like that can stay calm for a while, but it is loaded with tension, and tension in a crowd of giant planets does not dissipate. It accumulates quietly until something gives. It is worth noticing how much of your own body traces back to this sorting of the disk. The rock beneath your feet, the iron in your blood, the water in every cell, all of it was arranged by where the frost line fell and how the material gathered on either side of it. The Earth formed in the warm inner region, which is why it is dense and rocky rather than a ball of gas, and why it held on to relatively little of the light material that the giants gorged on. Much of the water that fills our oceans may even have been delivered later, carried inward from beyond the frost line by the very same stirring of icy bodies that the instability set loose. So the division of the disk into an inner realm of rock and an outer realm of ice is not a distant abstraction. It is written into the composition of the world you're lying on and into you. Consider what a narrow window the whole sorting depended on. The gas that let Jupiter and Saturn balloon into giants lasted only a few million years before the young sun swept it away, and a few million years, against the 4.5 billion the solar system has lived since, is the thinnest sliver of time. Form a little too late, and there is no gas left to gather, and you end up an ice giant rather than a gas giant, or smaller still. The difference between the kinds of worlds out there came down to a race against a vanishing resource, a race measured in the first moments of the solar system's life, and the losers of that race, the worlds that grew almost large enough but reached for the gas a moment too late, are the same ice giants that the coming instability would find easiest to throw away. Timing made them, and timing would unmake them. Part 5. The Simulations That Refuse to Work. Here is one of the most quietly disturbing facts I know about our own solar system. When scientists try to recreate it from scratch, it does not work. Our home, the arrangement of worlds we take as the very definition of normal, turns out to be remarkably hard to reproduce. And the way it fails is the thread that leads us to the missing planets. Let me explain how this kind of work is actually done, because it is more clever than you might expect, and understanding it is the key to trusting, or reasonably doubting, everything that follows. Scientists cannot rewind the real solar system, so instead they build a model of it inside a computer, a simulation that obeys the laws of gravity, and they set it running from some plausible starting point. They begin with a young sun and a disk of material, or with a set of freshly formed giant planets in their crowded early orbits, and then they let the simulation run forward through millions and billions of years of gravitational tugging, watching how the orbits evolve, how the planets push each other around, where everything ends up. Then they do something important. They throw away every run that ends up looking nothing like us, and they keep only the runs that produce something resembling the solar system we actually observe. It is a way of asking a precise question. Out of all the ways a system like this could have unfolded, which starting conditions lead to a result that matches our home? And the answer that keeps coming back is the reason we are here tonight. If you start the simulation with only the 4 giant planets we have today, Jupiter, Saturn, Uranus and Neptune, in reasonable early orbits, and let it run, it very rarely produces anything like our solar system. The orbits come out wrong, the spacing comes out wrong, the planets end up too stirred up, or in the wrong places, or the inner rocky worlds get wrecked in the process. 4 giants, by themselves, do not naturally settle into the calm, well-separated arrangement we see. The math resists it. Our solar system, starting from 4 giants, is a rare and awkward outcome, hard to reach and easy to miss. But then the researchers tried something. They added a planet. They started the simulation not with 4 giants, but with 5, slipping an extra ice giant into that crowded early group, a world roughly the size of Uranus or Neptune. And suddenly, the simulations got better. With 5 giants to begin with, the system could go through its violent phase and then, crucially, eject the extra planet, throwing it clean out of the solar system, and the survivors would settle into orbits that look far more like the ones we actually have. The extra planet acts almost like a pressure valve. It absorbs the worst of the chaos, takes the hardest gravitational blow, and gets flung away into interstellar space, and by leaving, it lets everything else fall into a stable, life-permitting configuration. In many of the most successful reconstructions, that 5th planet is ejected roughly 600 million years after the solar system formed. I find it hard to overstate how strange this is when you really sit with it. The best explanation we have for why our solar system looks the way it does is that it used to have another planet, and that this planet was thrown away. Our stability is not the natural result of the 4 giants we can see. It is the result of a 5th giant we cannot see, a world that had to be sacrificed, expelled into the dark, for the rest of the arrangement to make sense. We are, in a very real way, living in the calm that another planet's banishment left behind. And some of the models work even better with 2 extra giants rather than 1, which is where the idea of losing a pair of planets comes from. The exact number is uncertain, and I will be careful about that in a moment. But the basic result, that we need at least 1 extra world and possibly 2, has held up across many independent groups running many independent simulations. It is not one lucky run that somebody fell in love with. It is a pattern that keeps reappearing. There is a beautiful and slightly frightening detail buried in this that I have to share, because it connects the lost planet directly to your own existence. In these simulations, when the 5th giant is ejected, the way it leaves matters enormously for the inner solar system. As the giant's orbits go unstable, Jupiter, the heaviest of them all, tends to shift its orbit. If Jupiter migrated slowly and smoothly inward, sweeping through the inner solar system, it would have been a disaster. Its gravity would have scattered the small rocky planets, flinging Earth and its neighbours into chaos, possibly out of the system entirely, possibly into the Sun. But in the successful models, Jupiter does not migrate smoothly. Instead, the encounter with the doomed 5th planet lets Jupiter jump, shifting its orbit in a sudden step rather than a slow sweep. Scientists sometimes call this the jumping Jupiter scenario, and the planet that gives Jupiter the kick it needs to jump, sparing the inner worlds, is the very planet that gets ejected in the process. In other words, the world that was thrown away may have taken the blow that would otherwise have fallen on us. It jumped Jupiter out of our danger zone on its way out the door. I want to pause on the doubt again, because intellectual honesty demands it, and because you deserve it. All of this rests on simulations, and a simulation is not a photograph. It is a model, and a model is only as good as the assumptions poured into it. Different starting conditions can lead to similar endings, and it is genuinely possible that some future insight will show that 4 giants could have produced our solar system after all, through some path we have not yet found. The lost planets are inferred, not observed. Nobody has ever seen them. If you want to keep a portion of your mind skeptical, that is not just allowed, it is correct. But here is what gives the idea its weight. It does not stand on the simulations alone. If the only evidence were that the math works better with an extra planet, we could shrug and call it a curiosity. What makes the story serious is that the simulations predicted violence, chaos, close encounters, planets knocked around and moons destroyed, and then, when we went and looked at the real planets, we found the scars that violence should have left. The tilt of Uranus, the shattered moons, the bombardment of the inner worlds. The models told us where to look for wounds, and the wounds were there. That is the part that is hard to explain away, and that is where we turn next, to the moment the crowded giants finally lost their balance and the calm ended. Let me make the simulation method a little more concrete, because trusting it, or reasonably doubting it, depends on seeing how it actually works. What the researchers build is called an n-body simulation, from the idea of tracking n separate bodies, in this case the Sun and the planets, and often huge numbers of smaller objects, and computing the gravitational pull of everything on everything else, step by tiny step, forward through time. It is nothing but Newton's law of gravity, applied relentlessly, millions upon millions of times, letting the orbits evolve as they will. There is no fudging of the outcome. The computer simply does the arithmetic of gravity and shows you where everything ends up. The art is entirely in the setup, in choosing plausible starting conditions, and then in honestly comparing the endings to the real solar system. And here is the crucial discipline that keeps the method honest. The researchers run the simulation not once but thousands of times, with slightly different starting arrangements each time, because the system is chaotic and small. Changes in the start lead to large differences in the end. Then they ask, of all those thousands of runs, which ones produce something that genuinely resembles our solar system? The right number of giants in roughly the right orbits, the inner planets intact, the debris distributed the way we observe it. The runs that match are rare, and the interesting question is what those rare successful runs have in common. What they have in common, again and again, is an extra planet at the start that gets ejected along the way. 4 giant starts almost never succeed. 5 giant starts with the 5th thrown out succeed far more often. That is not one scientist's pet result. It has been reproduced by independent groups running independent code, and its persistence is what gives it weight. The jumping Jupiter detail deserves one more pass because it is the piece that ties the lost planet to your own existence most directly. In the successful runs, as the instability unfolds, the doomed extra giant has a close encounter with Jupiter, and that encounter does 2 things at once. It flings the extra giant outward, hard enough to eject it, and by conservation of momentum it shifts Jupiter's own orbit inward in a sudden jump rather than a slow slide. That sudden jump is what spares the inner solar system. A slow inward migration by Jupiter would have swept resonances through the rocky planets like a plough, scattering Earth and Mars and Venus, possibly destroying them. The jump skips past that danger. So the same event that exiled the extra planet also protected the Earth, and the two are not separate strokes of luck. They are the same stroke seen from 2 sides. The planet that was thrown away is, in a real sense, the reason the ground beneath you stayed put. One more feature of these simulations deserves mention, because it speaks to how seriously we should take them. The researchers do not only check whether the final giant orbits look right, they check a whole list of independent features at once: the orbits of the giants, the survival of the inner rocky planets, the structure of the icy belt beyond Neptune, the swarms of asteroids that share Jupiter's orbit, the record of the bombardment. A successful run has to match all of these simultaneously, not just one. It is a demanding test, and the reason the extra-planet scenario is taken seriously is that it passes far more of these tests together than the 4-giant scenario does. When a single added assumption, an extra planet that gets ejected, improves the match across many independent features at once, that is exactly the kind of result scientists learn to trust, because it is hard to get so many things right by accident. Let me also address the honest discomfort some people feel when a whole story rests on computer models, because that discomfort is reasonable and worth answering directly. A model is not reality. It is a careful imitation of reality built from the laws we trust. But the reason we lean on these particular models is that the laws they rest on, chiefly Newton's law of gravity, are among the most thoroughly tested ideas in all of science, confirmed to extraordinary precision across centuries of observation. From falling apples to the orbits of spacecraft, we navigate to distant planets with pinpoint accuracy. When a simulation uses only that law and asks where the planets go, it is not inventing physics. It is applying physics we already trust completely. The uncertainty is not in the law. It is in the starting conditions, in how many planets there were and where exactly they began. And that is precisely the uncertainty the researchers probe by running the simulation thousands of times over. The method is humble about what it does not know and rigorous about what it does. Part 6. Chaos, Resonance, and the Bombardment. For a stretch of time after the planets formed, the solar system held its breath. The giants turned in their crowded orbits, pulling on one another, the tension building slowly, invisibly, the way strain builds in the rocks along a fault line long before an earthquake. From the outside, in those years, everything might have looked calm. But calm built on rising tension is not the same as calm built on rest. It is a countdown. And the mechanism counting down was something physicists call resonance, which is worth understanding, because it is the trigger that broke our solar system open. Resonance is what happens when small pushes arrive in perfect rhythm. You already know it from a playground swing. If you push a child on a swing at random moments, nothing much happens. The pushes fight each other and cancel out. But if you push in time with the swing, a small push at the same point in every arc, the motion grows and grows, each push adding to the last, until a series of gentle nudges builds into a wide, powerful arc. Gravity does the same thing to orbits. When two planets circle the Sun with periods that fall into a simple ratio, so that one completes exactly 2 orbits for every one the other completes, say, their gravitational tugs start arriving in rhythm, and just like the pushes on the swing, those rhythmic tugs add up. A tiny, harmless pull, repeated in perfect time over millions of years, can grow into a force strong enough to reshape an entire orbit. In the crowded early solar system, as the giant planets slowly shifted, they eventually drifted into exactly this kind of rhythmic relationship. 2 of the giants, most likely Jupiter and Saturn, crossed into a resonance, their orbital periods locking into a simple ratio. And once that happened, the gentle tugs that had been harmless for so long began to arrive in time, and to build and to feed on themselves. The tension that had been quietly accumulating in the crowded system was suddenly released all at once through this resonant amplification. The orbits, which had held their fragile arrangement for hundreds of millions of years, went unstable in what was, on cosmic timescales, almost an instant. And when a system of giant planets goes unstable, it does not wobble politely. It erupts. The orbits stretch and swing. The giants begin to cross one another's paths, coming close, hurling one another around with their gravity. A crowd of massive worlds that had been marginally balanced becomes a gravitational free-for-all, each planet flung onto a wilder path by its encounters with the others. This is the lurch I promised you, the moment the tidy picture broke. Somewhere in this chaos, the extra giant, the 5th planet, and perhaps a 6th, had their fatal encounters. They came too close to Jupiter, the heaviest and most dangerous of the giants, and Jupiter did to them what it does to almost anything that comes too near. It slung them away with such force that their orbits stretched out beyond the edge of the solar system, and they were gone, cast out into interstellar space, never to return. And in the same convulsion, Jupiter itself jumped, shifting its orbit in a sudden step that, as we saw, spared the inner rocky worlds from being scattered. But the inner worlds did not escape untouched, because when the giants' orbits went wild, they did not only throw out planets, they stirred the entire outer solar system, the enormous population of leftover icy bodies and rocky debris that had never been swept up into a planet. The material that today survives as the distant comets and the icy belt beyond Neptune. As the giants lurched, their gravity flung enormous numbers of these smaller bodies inward, hurling comets and asteroids down toward the Sun, straight through the region where the rocky planets orbit. The result was a rain of destruction that fell on the inner solar system, a period so intense that it has a name. Scientists call it the Late Heavy Bombardment, and its fingerprints are still visible tonight, because you can see some of them with your own eyes. Look at the moon. The next clear night, look at the face of the moon, and notice that it is covered in craters, especially the bright highland regions, pockmarked and battered, scar upon overlapping scar. Most of those craters are old, and a great many of them date to roughly the same window of time, around 4 billion years ago, a few 100 million years after the solar system formed. That clustering is not random. It is the record of the bombardment, the moment the destabilized giants flung a storm of debris into the inner solar system, and the moon caught thousands of the blows and, having no wind or rain or shifting continents to erase them, kept every scar. The Earth was hit just as hard, harder even, because it is larger and its gravity pulls in more. But the Earth is alive in a geological sense, its surface constantly reworked by weather and moving crust, and so it has erased almost all of its craters. The moon remembers what the Earth has forgotten. When you look up at that battered face, you are looking at a preserved record of the same catastrophe that threw away 2 planets. I want you to stand inside that moment, on the surface of the young moon, because it makes the abstraction real. Imagine you are there, 4 billion years ago, on that airless grey plain, under a black sky. The Earth hangs overhead, young and hot, its surface still glowing in places, and there is no calm anywhere. The sky is streaked with falling light. Comets and asteroids, some the size of mountains, are raining down across the inner solar system, and around you the ground shudders again and again as impacts strike, throwing up walls of debris that arc slowly through the airless dark and fall back in silence. Flashes bloom on the distant curve of the Earth where larger bodies hit. There is no sound, because there is no air to carry it, only the endless silent trembling of the ground beneath you, and the slow, relentless fall of fire from above. This went on, in waves, not for hours or years, but across a stretch of time longer than all of recorded human history multiplied thousands of times over. This was the solar system settling its accounts, the debris of the instability crashing home, and every one of those falling bodies had been set loose by the same event that exiled the lost planets. When it finally quieted, the solar system that emerged was close to the one we know. The surviving giants had settled into wider, calmer, better separated orbits, the ones drawn in the diagram. The rain of comets and asteroids tapered off. The inner worlds, battered but intact, cooled and steadied, and on at least one of them, in the pause that followed the violence, something began that would eventually lead to you. But two worlds were missing. They had been thrown out during the chaos, and the solar system had rearranged itself around their absence, and the planet that took the hardest, most direct blow of all, the one whose wound is still the clearest to read, was not thrown out. It survived, knocked onto its side, its moons torn apart, spinning ever since as a monument to the violence. That planet is Uranus, and its scars are the most vivid evidence we have, so let us go and read them. The particular resonance that most likely triggered everything deserves a name, because naming it makes the mechanism feel less mystical. The leading candidate is the 2-to-1 resonance between Jupiter and Saturn, the point at which Jupiter completes exactly 2 orbits for every one that Saturn completes. When the 2 largest planets in the solar system fall into that rhythm, their gravitational tugs on each other and on everything else line up and reinforce, and the whole outer system feels the amplified pull. As the giants slowly migrated in their early orbits, by exchanging momentum with the surrounding disk of small bodies, they drifted toward that resonance, and when they reached it, the accumulated tension released. It is a remarkable thought that the calm of our entire solar system may have hung, for hundreds of millions of years, on 2 planets slowly approaching a simple ratio, and that crossing it was the trigger that fired the instability. I should be honest that the timing and even the reality of the late heavy bombardment are debated among scientists, and this is a good place to practice the caution I promised. The classic picture holds that the bombardment was a distinct spike, a sudden surge of impacts around 4 billion years ago, driven by the giant planet instability. Some researchers argue instead that the impacts declined more gradually, and that the apparent spike is partly an artifact of where our moon rock samples happen to come from. The debate is real and unresolved, but it does not undo the central point. Whether the inner solar system was bombarded in one sharp spike or a long tapering rain, the source was the same, the stirring of the outer debris by the shifting giants, and the craters on the moon are genuinely there, genuinely ancient, and genuinely the record of a violent era. The disagreement is about the shape of the curve, not about whether the violence happened. Stay a little longer on that airless plane with me, on the young moon under the falling sky, because there is a detail that makes it land even harder. Every crater you would see forming around you, every wall of debris thrown up and falling slowly back in the silence, is being carved by an object that was set loose by the same event that exiled the lost planets. The comet streaking down toward the young Earth and the planet drifting out toward permanent exile are 2 ends of one gravitational convulsion. The solar system in that era was redistributing itself with tremendous violence, hurling some bodies inward to crash and burn and flinging others outward to freeze in the dark. And when it was finally done, when the last of the loose debris had either struck home or settled into a stable orbit or been cast away, the survivors found themselves in the calm, well-separated arrangement of the drawing. The calm was not the absence of the violence, it was its residue, what was left once everything that could fall had fallen. Think of the whole episode as a single machine with an input and an output. The input was a crowded, tense arrangement of giant planets that had held together for hundreds of millions of years. The output was the calm, well-separated solar system of the drawing, minus 1 or 2 planets, plus a scattered record of debris and craters and a tilted, wounded Uranus. The instability was the machine that turned the one into the other, and it ran fast once it started, in perhaps only a few million years, a blink against the age of the solar system. That speed is part of why the era is so hard to study. It did not leave a long, layered record of gradual change. It left a set of abrupt scars, the marks of a rapid convulsion, which is exactly why reading them requires the patient reconstruction we have been doing rather than a simple reading off of a timeline. It is humbling to realize that the tidiest feature of our solar system, the calm, generous spacing between the giant planets, is not a sign of gentle origins but the fingerprint of the convulsion itself. The giants are far apart today precisely because the instability flung them apart and then, with the troublemaker ejected, let them settle where they no longer disturbed one another. Order here was not preserved from the beginning. It was manufactured by chaos and then frozen in place once the chaos ran out of fuel. Every time you see the planets drawn in their comfortable, well-separated lanes, you're looking at the settled aftermath of the very event that lost us a world. The spacing is not the opposite of the violence. It is the violence, cooled and set. Part 7. The Wound on Uranus. Of all the worlds in the solar system, Uranus is the one that wears its history most openly, and once you know how to read it, you cannot look at that pale, quiet planet the same way again. It is tipped over onto its side, tilted by about 98 degrees, rolling around the sun instead of spinning upright like everything else. We touched on this earlier as the first scar. Now we can understand what it really means, and why the study I opened with treats it as the key to the whole story. Start with the simple physical fact, because it does the heavy lifting. Planets inherit their spin from the disk they form in, and that disk turns in one direction, so planets should come out spinning more or less upright, their poles pointing roughly the same way as the poles of their orbit. Most of them do. Uranus does not. To tip a planet as massive as Uranus all the way onto its side, you need an enormous input of energy delivered in a very particular way, either a direct collision with another large body or an extremely close and violent gravitational encounter with something big. There is no gentle, gradual process that lays a planet down like that. The tilt is a record of a single catastrophic event, or a small number of them, frozen into the planet's motion and preserved for 4 billion years because there is nothing out there to undo it. Uranus has been lying on its side turning ever since whatever knocked it over. The wound never healed because in space, without erosion, wounds do not heal. They just keep turning. Now here is where the newer work sharpens the picture. If Uranus was simply a planet that got hit and tipped over, that would already be dramatic. But the tilt does not stand alone. Uranus has a family of moons, and those moons orbit around the tipped-over equator of the planet, circling the same sideways axis the planet spins on. That is a crucial clue. It means that whatever tilted Uranus did not just knock the planet over and leave the moons behind in their old orbits. The moons are aligned with the new tilted spin. So either they formed after the tilting event, out of material thrown into orbit by it, or they were dragged into their new alignment by the same violent process. Either way, the moons are part of the crime scene, not innocent bystanders, and when the researchers behind the 2026 study looked closely at those moons, running their models of what a close encounter with a wandering giant would do to the Uranian system, they found something stark. The moons should not have survived intact. In their reconstructions, the survival probability of Uranus's moon system through the instability was low, under 15%. In most versions of events, the original moons were destroyed. Let me slow down and put you inside that destruction, because it is the beating center of this whole video, the moment the abstract instability becomes something you can almost see. Imagine you are floating near Uranus, 4 billion years ago, in the middle of the chaos, as one of the wandering giants, a world the size of Neptune, swings in on its wild, unstable orbit and comes close. At first it is a point of light among the stars, a little brighter than the rest. Then, over hours and days, it grows. It swells from a point into a disk, from a disk into a looming presence that fills more and more of the sky. A pale, banded world sliding closer, silent, enormous, indifferent. And as it nears, its gravity begins to reach into the Uranian system and pull. The moons, which had been circling Uranus in calm, ordered rings, feel their orbits stretch and warp. The intruder's pull competes with Uranus's own, and the delicate balance that held the moons in place comes apart. Some are torn outward, some are dragged inward, and in the tangled, crossing paths that follow, the moons begin to collide not gently, but at speeds of thousands of miles an hour, ice smashing into ice with enough force to shatter both. Where there had been solid, ordered worlds, there is now an expanding cloud of glowing fragments, a ring of pulverized ice spreading around the tilted planet, catching the distant sunlight. The intruder, having done its damage, swings on past and away, out toward its own exile, and behind it, Uranus turns, newly knocked onto its side, wrapped in the debris of its own shattered moons. But the story does not end with destruction, and this is the part I find strangely moving. That cloud of shattered ice did not simply disperse and vanish. Over long ages, under its own faint gravity, the debris began to gather itself back together, fragment finding fragment, clumps growing into larger clumps, the same patient process of accretion that built the planets in the first place, now rebuilding moons out of the rubble of the old ones. The Uranus we see today has moons, and some of them may be these second-generation moons, worlds assembled from the wreckage of their predecessors, and one of them, in particular, looks exactly like what you would expect a moon rebuilt from debris to look like. Its name is Miranda, and it is one of the strangest objects in the entire solar system. Miranda is small, only about 300 miles across, but its surface is a chaotic patchwork, a jumble of mismatched terrains slammed together with no apparent order. There are regions of old, cratered ground sitting right beside regions of grooved, ridged, folded terrain, sharp boundaries between them, as if someone took pieces of several different worlds and pressed them into one. It has a cliff, a single towering drop called Verona Rupes, that may be the tallest cliff in the solar system, plunging as much as 12 miles from top to bottom. If you stepped off the edge of Verona Rupes, in Miranda's feeble gravity, you would fall for something like 10 minutes before you reached the bottom. For a long time, Miranda's jumbled, assembled-looking surface was a genuine puzzle. Why would a small moon look as though it had been broken apart and put back together? And the answer the new picture offers is simple and chilling. Because it was. Miranda may quite literally be a moon reconstructed from the shards of an earlier catastrophe, its mismatched surface the seams where the pieces came back together. Its Frankenstein face is the scar, still legible, of the day the intruder came. This is what I meant when I said the scars are still here. They are not metaphors. The tilt of Uranus is a scar you can measure. The shattered and reassembled moons are a scar you can photograph. Miranda's stitched-together surface is a scar you can, in principle, one day stand on. Everything about Uranus, the sideways spin, the aligned moons, the low odds that any of its original satellites survived, the patchwork face of Miranda, all of it fits one story. This planet lived through the instability at close range. It took a blow that exiled its siblings and knocked it onto its side and destroyed its moons. And it survived, and it has been turning ever since, carrying the wound in plain sight, waiting 4 billion years for someone to come along who could finally read it. We are that someone, and having read the wound, we have to face the harder question. The siblings that were thrown out, the planets that did not survive as Uranus did, where are they now? What became of a world that gets cast out of the only home it ever knew? We have only ever seen Uranus up close once, and that single visit is worth remembering, because it is a reminder of how thin our direct knowledge of these outer worlds really is. In 1986, the Voyager 2 spacecraft swept past Uranus, the only time any machine from Earth has visited that planet, and for a few hours it sent back the only close photographs we have ever taken. Everything else we know about Uranus, we know from a distance through telescopes, straining to resolve a pale point of light. That lone flyby showed us the tilted planet and its strange moons, including Miranda with its jumbled, stitched-together face, and much of what we understand about the Uranian system still rests on those few hours of data from 4 decades ago. There are proposals to send another mission, but Uranus is so far away that any spacecraft would take well over a decade simply to arrive. For now, the crime scene sits mostly unvisited, its scars red at long range. The tilt gives Uranus the strangest seasons of any planet, and describing them makes the violence of its history vivid in a different way. Because the planet is knocked over onto its side, its poles take turns pointing almost directly at the Sun as it moves along its orbit. And since Uranus takes about 84 Earth years to circle the Sun once, each pole spends roughly 42 years in continuous sunlight, followed by roughly 42 years in continuous darkness. Imagine a night that lasts 42 years, a single unbroken darkness longer than most human careers, followed by a day of equal length. That is the rhythm the ancient blow imposed on Uranus, a rhythm no other planet shares, and it is a direct ongoing consequence of whatever knocked the world down. The seasons of Uranus are, in effect, the scar made visible in the pattern of its light and dark. Now return with me to the moment of destruction, because I want to give it the full weight the new study implies. When the researchers found that the survival probability of the Uranian moon system through the instability was under 15%, they were saying something stark in the dry language of statistics. They were saying that in more than 85% of their reconstructions, the moons that formed with Uranus did not make it. They were torn from their orbits, sent onto crossing paths, and destroyed in collisions with one another. Picture it once more from up close. The intruding giant fills the sky. Uranus's moons, which had circled in calm order, begin to slip their orbits as the intruder's gravity wars with the planet's own. They drift, they cross, and then they begin to strike each other, ice against ice at speeds no material can survive, each collision spraying out a glowing sheet of fragments. Where there had been a family of ordered worlds, there is now a spreading ring of pulverized ice, catching the far sunlight, wrapping the tilted planet in the shattered remains of its own children. And out of that ring, over long ages, new moons gathered, Miranda perhaps among them, built from the rubble, wearing the seams of their reassembly on their surfaces to this day. It is worth dwelling on the strangeness of Miranda's tallest cliff a moment longer, because it makes the abstract violence tangible in a way numbers alone cannot. Verona Rupes rises so far, and Miranda's gravity is so weak, that the little moon behaves in ways that defy earthly intuition. A pebble nudged off that cliff would not plummet. It would drift down almost lazily, taking minutes to fall, as though the whole world were operating in slow motion. And yet that gentle, low-gravity surface is precisely the kind of place a moon rebuilt from debris would produce. A small body with just enough gravity to gather the fragments back together, but not enough to smooth them into a tidy sphere. The mismatched terrains, the sharp boundaries, the improbable cliff, all of it fits a world assembled from pieces rather than formed in one clean act. Miranda is, in a sense, a monument that was never meant to be a monument, a moon that happens to preserve in its very shape the memory of the day its predecessors were destroyed. When you set all of Uranus's oddities side by side, the case stops feeling like a collection of coincidences and starts feeling like a single confession. A planet knocked onto its side, a family of moons aligned with that sideways spin rather than with the plane of the solar system. Moons that the models say should mostly have been destroyed, and at least one Miranda that looks exactly like a world reassembled from wreckage. No single one of these on its own forces the conclusion, but all of them together, pointing the same direction, are hard to explain by anything other than a violent encounter during the era when the giants were losing their balance. That is how a case is built in the historical sciences, not from one decisive proof, but from many independent clues that only make sense together. Uranus is the planet where the most clues converge, which is why it sits at the centre of the newest work and at the centre of this story. Part 8. The Exile. We have spent this whole journey looking at what stayed. The tidy rings, the surviving giants, the tilted planet, the rebuilt moons. Now I want to turn and look at what left. Because somewhere in that ancient convulsion, one or two entire worlds were thrown out of the solar system, and their fate is, to me, the most haunting part of the whole story. To understand it, we have to think carefully about what it actually means for a planet to be ejected, and it is worth doing slowly because the physics and the feeling are tangled together here in a way that is hard to shake. When Jupiter flung the extra giant away, it did not send it on a long looping orbit that would eventually bring it back. It gave the planet enough speed to break free of the sun's gravity entirely, to cross the threshold that separates a bound orbit from an open escape. Below that threshold, an object is a captive. It will always fall back no matter how far out it swings. Above it, the object is free, and freedom, in this case, means exile. The ejected planet climbed away from the sun, slowing as it went, the way a ball slows as it rises, but it never slowed enough to stop and fall back. It kept climbing, out past the orbits of the surviving giants, out past the icy belt of debris, out past the faint cloud of distant comets that marks the edge of the sun's domain, and then out past even that, into the open space between the stars. And there it kept going, and it is going still. Think about what that world lost, because it lost everything a planet can lose. It formed in the warm, crowded disk alongside Jupiter and Saturn, and the worlds that became Uranus and Neptune. It was, in every meaningful sense, their sibling, built from the same cloud, warmed by the same young sun, a full-fledged planet with a body of gas and ice, possibly with moons of its own circling it, possibly with rings. It had a place in the family. And then, in a single violent encounter, lasting perhaps only days, it was stripped of all of it. As it climbed away, the sun that had lit it and warmed it for hundreds of millions of years began to shrink behind it. First it became smaller, but still a disk, still clearly a sun, then smaller still, until it was just the brightest star in the sky. And then, as the planet drifted further into the dark, even that faded, until the sun was one point of light among thousands, indistinguishable from the other stars, no longer a source of warmth or day or seasons, just another distant pinprick in a black sky. The planet's day never came again. Its warmth bled away into space and was not replaced. It fell into a cold and a darkness that would last not for a season, not for an age, but forever. There is no path back. The physics forbids it. A world that crosses that threshold is gone for good. I keep coming back to a phrase for these lost worlds, and I cannot improve on it. Cold, dark, and alone. That is what ejection does to a planet. It takes a world as real and complete as any in our sky, and it condemns it to drift between the stars, cold, dark, and alone, for the rest of the life of the universe. And there is something in that fate that reaches past the physics and lands somewhere more personal, because it is a kind of loss we understand. We know what it is to be cut off from warmth, to be cast out, to lose the place we belonged. And here is that experience written on the largest possible scale, a whole planet exiled from its home, carrying with it, if it had moons, its own small family into the endless dark. These worlds were not destroyed. That is the part that stays with me. They were not shattered like Uranus's moons or vaporized in a collision. They survived, intact, whole planets still, and that is almost worse, because it means they are still out there, somewhere, right now, tonight, coasting through interstellar space, as real as the ground under your feet, and utterly alone. I have to be careful and honest here, because this is where the storytelling could run ahead of the evidence, and this channel does not do that. We do not know that there were exactly 2 ejected planets. The models support 1, and often work better with 2, but the number is genuinely uncertain, and anyone who tells you we know for sure is overstating the case. We do not know precisely how large the lost worlds were, though ice giant size, something like Uranus or Neptune, is the best guess, and we cannot point a telescope at a specific object and say, there, that is one of ours. The ejected planets, if they exist, left 4 billion years ago, and in that time they have travelled an incomprehensible distance. They could be anywhere in a huge swathe of the galaxy by now, cold and unlit and nearly impossible to detect against the black. So when I describe them drifting out there, understand that I am describing the most reasonable reconstruction we have, not a confirmed sighting. The exile is inferred from the same scars as everything else, the tilt, the shattered moons, the simulations that need extra planets to work. But here is the thing that turns this from a sad story about our own solar system into something much larger and stranger. If our solar system threw away 1 or 2 planets, then it is almost certainly not unique. The same physics, crowded giants, resonance, instability, ejection should play out around other stars too, over and over, across the galaxy and across cosmic time, which means the space between the stars should not be empty. It should be populated. It should be full of exiled worlds, planets thrown out of the systems that made them, wandering in the dark. And when astronomers went looking for exactly that, for planets drifting alone through interstellar space with no star to orbit, they found them. They are real, they have a name, and there may be more of them in our galaxy than there are stars. So let us follow our lost siblings out into the dark and meet the wanderers. The word ejection sounds clean and quick, so let me slow it down into what it would actually have been, because the reality is stranger and sadder than the word. A planet is not flicked away in an instant like a marble off a table. As the doomed giant had its fatal encounter with Jupiter, it was accelerated onto a path that would carry it out of the solar system, but the leaving itself took time. The planet climbed away from the sun over years, then decades, then longer, slowing as it rose, the way anything slows as it climbs against gravity. For a long stretch it might almost have seemed to hesitate, coasting outward through the cold, the sun shrinking behind it but still visibly a sun, and then, gradually the outcome became certain, as the planet's speed stayed just above the threshold of escape, and it failed, month after month, year after year, to fall back. The exile was not a single violent moment. It was a long, slow departure, a farewell drawn out across a human lifetime and more. If the ejected planet carried moons, and an ice giant may well have, then it did not leave alone, and there is something in that which makes the loss harder rather than easier. The moons, bound tightly to their planet, would have been carried along into exile with it, a small family cast out together, still circling their world as that world fell away from the sun into permanent night. So the exile may not have been the banishment of a single body, but the removal of an entire little system, a planet and its moons, torn from the warmth and sent as a unit into the dark. Whatever faint processes those moons had, whatever slow tides and quiet changes, they would have continued out there in the black, a miniature clockwork still turning around a world that no longer had a sun. That image stays with me more than almost any other in this whole story, a lit world going dark with its moons still faithfully circling, coasting together into a night without end. And here is the thought that turns the sadness into something sharper. Everything I have just described, the slow climb, the shrinking sun, the family carried into exile, could as easily have been our fate. The only reason the Earth was not the world climbing away into permanent dark is the direction an ancient gravitational blow happened to point. In the runs of the simulation where Jupiter migrates the wrong way, it is the inner planets that get scattered, flung outward or into the sun, and in some of those runs a rocky world not so different from ours is the one cast out. We are here, warm and lit, not because we were protected, but because the chaos happened to spare us while it exiled someone else. The lost planets took the fate that could have been ours. When you look up at the night sky and find it calm, remember that the calm was bought, and that the price was paid by worlds that are out there still, cold, dark, and alone. There is a temptation, when a story is this sad, to want a rescue, some twist where the lost worlds are found again or were never really lost. I cannot offer you that, and I would not want to, because the honesty is part of what makes the story worth telling. The physics of escape is unforgiving. Once a planet crosses the threshold that separates a bound orbit from an open escape, there is no gentle mechanism to reel it back. It does not slow, stop, and return, the way a ball thrown upward returns to your hand, because it was given more than enough speed to defeat the sun's grip entirely. It coasts outward forever, its speed settling toward a small, steady drift that carries it further from home with every passing year. 4 billion years of that drift have placed the lost worlds at distances the mind cannot hold, and the same 4 billion years lie ahead of them, and the 4 billion after that, an exile with no far shore. The kindest true thing I can say is that they do not suffer it, because they cannot know it. Only we, looking outward from the warmth, can feel the weight of where they went. Part 9. The Wanderers in the Dark. Somewhere beyond the edge of our solar system, in the space between the stars, there are planets with no sun. They are called rogue planets, or free-floating planets, and for most of human history we did not know they existed. We assumed that planets came with stars, that a world without a sun to orbit was a kind of contradiction. But we were wrong. The galaxy is full of worlds that belong to no star at all, drifting alone through the dark, and the story of how they got there is, in many cases, the same story we have been telling all night. They were thrown out. They are the exiles, from our system and from countless others, and there are so many of them that they change the way you have to picture the galaxy itself. Let me give you the numbers, because they are staggering, and then let me help you feel them. Careful surveys of the galaxy, using a clever technique that catches the faint gravitational signature of a dark, drifting world as it passes in front of a distant star, have led astronomers to estimate that our Milky Way galaxy contains somewhere around 1 trillion rogue planets. That is 1,000 billion worlds wandering alone, and some recent estimates run higher still, suggesting there could be as many as 20 times more rogue planets than there are stars, which would push the count into the tens of trillions. Take a moment with that. There are, by the best current reckoning, more sunless drifting planets in our galaxy than there are stars in the sky. Every point of a light you have ever seen at night is a star, and between and around all of them, unseen, coast far greater numbers of dark, lonely worlds, most of them never to be detected, never to be named, simply there, falling through the black. I want you to stand on one of them, because the numbers alone will not do it justice. So imagine you are on the surface of a rogue planet, one of the Exiles, perhaps even one of ours, one of the two worlds our own solar system cast out 4 billion years ago. Look up. There is no sun. There has not been a sun in your sky for longer than the Earth has had life. The sky is black, edge to edge, scattered with the distant, unwavering points of the stars, and among them, somewhere, is one particular star, unremarkable, no brighter than its neighbours, that was once close enough to fill your sky with light and warmth. That star is the sun. That was home. From here it is nothing, one pinprick among thousands, and it gives you no light and no heat at all. The ground beneath you is frozen far harder than any ice on Earth, chilled to within a few degrees of the coldest temperature the universe permits, a cold so complete that the air itself, if you had brought any, would freeze and fall as snow. Nothing moves, nothing changes. There is no day and no night, no seasons, no weather in the way we mean it, only the slow, silent, endless drift through the dark, at a speed that would take you thousands of years to cross the gap to even the nearest star. This is not a temporary hardship. This is the permanent condition of the world you're standing on, and it will remain so until the stars themselves burn out. And yet, and I say this to hold the terror and the wonder in balance, these worlds are not necessarily dead in every sense. Some rogue planets may keep a strange kind of warmth far inside, left over from their formation, or generated by the slow decay of elements in their cores, and it is at least possible, in principle, that beneath the frozen surface of some wandering world, insulated by miles of ice, there could be a hidden ocean of liquid water, kept from freezing by internal heat, drifting through interstellar space in total darkness. Whether anything could ever live in such a place is pure speculation, and I flag it clearly as speculation. But it is a thought that softens the loneliness of the picture just slightly. The idea that even a sunless exile might carry a warm, dark sea hidden within it, a last small ember of its origin, coasting through the night of the galaxy. It is the kind of possibility this channel loves precisely because we cannot yet know, and the not knowing is its own quiet gift. Here is what these wanderers mean for our story, and why I wanted to bring you all the way out here to meet them. When our solar system ejected its extra planets, it was not doing something rare or freakish. It was doing something the galaxy does constantly, a routine and repeated act of expulsion that has filled the space between the stars with drifting worlds. Our two lost planets, if they exist, are not orphans in an otherwise tidy universe. They are two among a trillion ordinary members of an enormous invisible population of the exiled, and that reframes everything about the drawing we started with. The tidy solar system with its planets safely held in their rings is not the default state of matter in the cosmos. It may be the exception. For every neat system like ours, there may be countless worlds that were cast out, that never found or that lost a stable home, that drift now in permanent dark. The calm sky above you is not the rule the universe follows. It is a rare and fragile piece of good fortune, and the far more common fate statistically is the one that befell our lost siblings, cold, dark, and alone. When you hold that up against the comfort of the diagram starts to look less like a picture of how things are, and more like a picture of how rarely things go this well. Which leaves one last uncomfortable question, and it is the one that keeps this from being ancient history. Is any of this really over? Or is the story of loss and instability still unfolding, quietly, even now, in ways we're only beginning to suspect? Because there are hints, out at the far edge of our own solar system, that the roster of our worlds may not be as settled as the drawing claims. And there is the quieter unease, the one that has been building underneath everything tonight, that the stability we are living in was never promised to last. The technique that revealed the Wanderers is clever enough to deserve a proper description, because it is how we know these dark, sunless worlds are really out there. It is called gravitational microlensing, and it rests on a prediction of Einstein's theory of gravity, that mass bends the path of light. When a dark object, like a rogue planet, passes almost exactly in front of a distant star, its gravity bends and focuses the star's light for a short time, causing the star to appear to brighten and then fade in a characteristic pattern, lasting hours or days. The planet itself is never seen. It gives off no light of its own. But its gravity leaves a signature on the light of the star behind it, a brief, telltale brightening, and by counting how often these brightenings occur across surveys of millions of stars, astronomers can estimate how many unseen wandering worlds must be drifting through the galaxy to produce them. It is another case of reading the invisible from the marks it leaves, the same forensic spirit that runs through this entire story. Those surveys are what led to the staggering counts, the estimate of something like 1 trillion rogue planets in our galaxy, with some analyses suggesting the true number could be many times higher still. And a new instrument is about to sharpen the picture dramatically. NASA's Nancy Grace Roman Space Telescope, designed in part to hunt for exactly these microlensing signatures, is expected to detect far more rogue planets than we have ever catalogued, and to give us a much better census of the wandering population. So this is not a settled number carved in stone, it is an active frontier, a count that is likely to grow and firm up over the coming years. But even the conservative estimates are enough to overturn the old assumption. The space between the stars is not empty. It is populated quietly by more dark worlds than there are points of light in the sky. Let me bring you back to the surface of one of them for a final moment, because I think the standing there is worth more than any statistic. You're on an ejected world. The frozen ground beneath you harder than any earthly ice, the sky black and unmoving above you, scattered with the fixed points of distant stars. There is no sun, and there has not been one for 4 billion years. And yet if the speculation about hidden warmth holds for a world like this, then far beneath your feet, under miles of frozen crust, insulated from the killing cold of space, there might be a sea of liquid water, kept from freezing by the slow heat of the planet's own interior, a dark ocean drifting through the galaxy in total blackness. Whether anything could ever stir in such a sea I do not know, and no one does, and I mark that clearly as the far edge of speculation. But the mere possibility softens the picture in a way I find quietly comforting. Even in exile, even cold and dark and alone, a wandering world might carry a warm sea hidden within it, a last ember of the fire that made it, coasting through the endless night. And out there, among the trillion wanderers, 2 of them may be ours. There is a psychological turn hidden in the rogue planets that I do not want to pass over, because it changes how the whole night lands. For most of the story, the lost planets are objects of pity, worlds we imagine as tragic exiles cast into the dark. But the sheer number of wanderers flips that picture around. If there are more sunless, drifting worlds in the galaxy than there are stars, then the tidy starbound solar system is not the norm from which the rogue planets fell away. It may be closer to the exception, and the wanderers closer to the rule. Seen that way, our lost siblings are not freaks of misfortune. They joined the majority. It is we, clinging to our warm star in our improbable calm, who are the unusual ones, the statistical outliers, living in a rare and fragile arrangement while the more common fate, drifting alone in the dark, plays out in enormous numbers all around us, unseen. One quiet thought before we move on, offered for the drifting mind. The trillion wanderers are not distant abstractions. Some of them are statistically closer to us right now than many of the stars we can name. A rogue planet could be drifting through the space between the sun and the nearest star at this very moment, dark and silent, and we would very likely never know unless it happened to pass in front of a distant star and betray itself by bending the light. The galaxy we picture as mostly empty, a scattering of stars in a great darkness, is in truth threaded with unseen worlds, moving slowly through the black on their long journeys to nowhere in particular. The dark between the stars is not empty. It is crowded with the exiled, and we're only just beginning to take their census. Part 10. The story isn't over. It would be comforting to treat all of this as ancient history, a violent chapter that closed 4 billion years ago and has nothing to do with the settled sky above us now. But the story may not be finished, and there are 2 reasons to think so. The first is a genuine open question at the far edge of our own solar system. The second is a quieter and more unsettling realization about the nature of the stability we live in. Let us take them in turn, carefully, because this is exactly the kind of territory where it is easy to say too much, and I would rather say the right amount. Start with the edge of the solar system. Far beyond Neptune, out in the cold belt of icy bodies that circle the Sun at tremendous distances, astronomers have noticed something curious. A number of the most distant of these objects have orbits that seem to be clustered together, tilted and aligned in a similar way, as if something were herding them, shepherding their paths with its gravity. On its own, a little clustering could be chance, or could be a trick of how we happen to have found these faint far objects. But the pattern has led some astronomers to propose that there may be another planet out there, unseen, far larger than the icy bodies it is nudging, orbiting the Sun in the extreme distance, so far out and so dim that we have never directly spotted it. This hypothetical world has a name, even though no one has confirmed it exists. It is called Planet 9. I want to be very clear about the status of this idea because it is easy to get swept up in it. Planet 9 is not confirmed. It is a hypothesis, proposed to explain the clustering of distant orbits, and it remains genuinely debated. The clustering might have another cause. The planet might not be there at all, but it is a serious idea taken seriously by serious people, and it connects to our story in a tantalizing way. Because if there really is a large distant planet out there, one obvious question is where it came from, and one possibility, among several, is that it is a relic of exactly the chaotic era we have been describing, a planet that was flung far outward during the instability, but not quite hard enough to escape entirely, left stranded on a lonely, enormous orbit at the edge of the Sun's reach. Another possibility is that it is a world our Sun captured from somewhere else, a rogue planet drifting by that got snagged by the Sun's gravity and pulled into a distant orbit, an exile from some other star that found a new and remote home with us. Both of these are speculation, and I mark them as speculation. But both connect the unfinished present directly to the violent past. The roster of our planets may not be as closed as the drawing suggests. There may be one more out there, a survivor or a stranger still waiting to be found. Now let me turn to the second reason the story is not over, which is less about a specific missing planet and more about a shift in how you see the whole arrangement. And I want to approach it in the honest spirit this subject demands, so let me first say plainly what we do and do not know. We are, in the end, trying to reconstruct a distant past from indirect evidence, and that is hard, genuinely hard. It is a little like trying to work out the origin of a single event, from clues scattered and eroded over 4 billion years. Different reconstructions can fit the same clues. The number of lost planets is uncertain. The details of the instability are debated. If you ask me to rate how confident we should be that our solar system lost precisely 2 planets in precisely the way I have described, I would not tell you it is settled fact. I would tell you it is a strong, well-motivated, actively studied idea, supported by several independent lines of evidence, and still open at the edges. That honesty is not a weakness in the story. It is the story. Because the thing we are least certain about is the exact history, and the thing we are most certain about is the general lesson, and the general lesson is the unsettling part. The general lesson is this: stability, out here, is not the natural resting state of things. It is an outcome, and often a rare one, produced by violence and luck. Our solar system did not settle into calm because calm is what solar systems do. It settled into calm because a particular sequence of catastrophes happened to end in a configuration that holds together after 1 or 2 planets were removed, after Uranus was knocked over, after the inner worlds were bombarded, after Jupiter jumped clear of our danger zone. Change any of those events and we might not be here. If Jupiter had migrated smoothly inward instead of jumping, the Earth might have been scattered into the dark and you would not exist to hear this. If the ejected planet had left in a slightly different direction, the whole inner solar system might have been rearranged. The calm we live in is not a foundation. It is a survivor. It is what happened to be left standing when the violence stopped. And here is the part that I find genuinely sobering, offered gently, because it is the emotional center of everything we have looked at tonight. The physics that threw away those planets did not switch off. Gravity still works the way it always has. The solar system is more settled now than it was in that early chaos, far more settled, and there is no catastrophe looming on any timescale you need to worry about in a human life, or in 1,000 human lives, or in 1,000,000. I want to be clear about that so you can sleep. But over the truly long span, the immense stretches of time this channel likes to sit inside, nothing guarantees the calm is permanent. The same laws that made our arrangement can, given enough time, unmake it. Our stability is a reprieve, not a promise. We are living inside the quiet aftermath of a demolition, and the quiet is real, and it is also, in the largest view, temporary. That is not a reason for fear. It is a reason for a particular kind of attention. The attention you pay to something precious precisely because it was never guaranteed and will not last forever. The tidy sky above you is a gift left behind by an ancient catastrophe. And gifts like that deserve to be looked at closely while they are here. The case for Planet 9 and the case against are both worth understanding, because the disagreement is a good example of science working honestly on an open question. The argument for it began when astronomers noticed that several of the most distant known objects beyond Neptune have orbits that appear clustered, pointing in similar directions and tilted in similar ways, when you might expect them to be scattered at random. Two researchers, working through the possibilities, proposed that the gravity of an unseen planet, several times the mass of the Earth, orbiting far out in the dark, could shepherd those distant objects into the observed pattern. That is the case for. The case against is that the clustering might be a mirage produced by the particular patch of sky where we have looked hardest, or that the combined gravity of many smaller distant bodies might produce a similar effect without any large planet at all. Both sides are argued by capable people, and the honest position today is that Planet 9 remains an intriguing hypothesis, not a confirmed world. Telescopes are searching. We do not yet know. But suppose for a moment that it is there, because the possibility connects so neatly to our story. If a large planet really does orbit the Sun in the far dark, one natural question is how it got onto such an extreme distant path, and two of the leading answers both lead straight back to the violence we have been tracing. The first is that Planet 9 is a survivor of the early instability, a giant that was flung far outward during the chaos but not quite hard enough to escape, left stranded on an enormous lonely orbit at the very edge of the Sun's reach, a planet that came within a hair of exile and just barely stayed. The second is that it is a captured stranger, a rogue planet from some other star that drifted too close to our young sun and was snagged by its gravity, an exile from a distant system that found an unlikely second home with us. I mark both as speculation, clearly, but either would mean that the story of the lost planets is not fully closed, that the count of our worlds may not be 8 after all, and that a relic of the ancient chaos, or a refugee from another one, may still be circling out there in the dark waiting to be found. And that leads to the quiet realization I want to leave with you before we turn toward the close, offered gently, in the honest spirit this subject demands. We cannot rate our reconstruction of the past as certain, and I would not pretend otherwise. Reconstructing a violent history from 4-billion-year-old scars is genuinely difficult, and reasonable scientists still argue over the details, the number of lost planets, the exact sequence, the shape of the bombardment. But the difficulty of pinning down the exact history sits right beside a lesson we can hold with much more confidence, and the lesson is the unsettling part. Stability, out here, is not guaranteed and not permanent. It is an outcome, produced by violence and luck, and preserved for now by the fact that the solar system has largely spent its early chaos. There is no catastrophe you need to fear in any span that matters to a human life, and I say that plainly so it can reassure rather than alarm. But across the immense reaches of time, this channel likes to sit inside. The same laws that arranged our worlds can rearrange them, and the calm we live in is best understood not as a fixed foundation, but as a long, precious reprieve. I find it worth saying plainly that not knowing is not the same as knowing nothing, because the difference is the whole spirit of this channel. We do not know exactly how many planets our solar system lost, or precisely how the instability unfolded, or whether a 9th planet waits in the far dark. Those are open questions, and they may stay open for a long time, some of them perhaps until a spacecraft finally visits the outer worlds again, or a new telescope sweeps up the faint light of the missing. But around those open questions sits a large body of things we do know with real confidence, that Uranus is tilted, that its moons are strange, that the simulations need extra planets, that rogue worlds fill the galaxy, that the moon carries the record of an ancient bombardment. The unknowns are surrounded by knowns, and that is the healthiest possible state for a subject to be in, because it means there is solid ground to stand on and a genuine frontier to wonder at, both at once. I want to leave the question of Planet 9 genuinely open, because the honest thrill of it is the not knowing. As you listen tonight, telescopes are sweeping the far reaches of the solar system, searching for a faint, slow-moving point of light that would confirm a ninth world, and they have not found it, and they may not, and they might. It is one of the few places in modern astronomy where a single planet, a major member of our own solar system, could still be hiding in plain darkness, waiting to be discovered by someone paying attention on the right night. Whether it turns out to be a relic of the ancient chaos, a captured stranger, or nothing at all but a trick of where we happen to look, the search itself is a reminder that our map of home is not finished. There may still be a world out there with our sun in its sky, uncounted, unnamed, and unseen. Part 11. The Scars and the Witness. We have travelled a long way backward tonight, from the tidy drawing all the way down into the violent birth of the worlds, and it is worth pausing here at the end to feel how far we have come from where we started. We began with the diagram you were shown as a child, the neat rings and the calm circles and the quiet promise that this is how things are and always have been, and we have watched that promise come apart layer by layer the further back we looked. Underneath the calm was violence. Underneath the order was chaos. Underneath the tidy family of 8 planets was an older, larger family that lost some of its members to the dark. The diagram was never wrong exactly. It was just the top layer. It was the surface of something with a long and terrible history underneath, and now that you have seen the history, I do not think you can look at the drawing the same way again. Let me gather the scars one last time, because together they tell a single story, and the story is remarkable. There is the tilt of Uranus, a planet knocked fully onto its side, still turning that way after 4 billion years, a wound that never healed because in space wounds do not heal. There are the moons of Uranus, aligned with that tilted spin, most of them probably destroyed and rebuilt from their own rubble, and among them Miranda, its patchwork surface stitched together from the fragments of an ancient catastrophe, carrying a cliff so tall you could fall from it for 10 minutes. There are the craters on the face of the moon, thousands of them clustered in a single ancient window of time, the preserved record of a rain of debris that fell on the inner worlds when the giants lost their balance. And there are the simulations, our attempts to rebuild our own home, which refuse to produce anything like us unless we start with more planets than we kept and throw the extras away. Each of these is a scar, and the scars are still here. That is the phrase I keep returning to, and I return to it now because it has quietly changed its meaning over the course of the night. At the beginning, the scars were clues, puzzles to be solved. By the end, they are something more. They are the whole meaning of the story. They are the evidence that order is thin, that our home was made by violence and luck, and that the calm we take for granted was purchased at the cost of worlds we can no longer find. And I keep thinking about those worlds, the lost planets, wherever they are tonight, cold, dark, and alone. We met them out in the interstellar night, 2 exiles among a trillion wanderers, drifting between the stars with no sun, in a cold near the very floor of what the universe allows, and they will drift like that forever, because the physics leaves no way back. When I started looking into this, I expected the terror of the title to come from something like danger, some threat, some monster in the dark. But that is not where the real unease lives. The real unease is quieter and stranger than fear. It is the recognition that those exiled worlds are not so different from our own. They formed in the same kind of disk, out of the same kind of cloud, warmed by the same kind of young star. The only thing that separates their fate from ours is the direction of an ancient gravitational blow. They were thrown out, we were spared, and there is no grander reason for it than that. No plan, no protection, just the way the chaos happened to fall. Our warm, lit, life-bearing world and their frozen, sunless exile are 2 outcomes of the same process, and we got the kind one. But I do not want to leave you in the cold, because there is a counterweight, and to me it is the most important thing in the entire story. Out of all the worlds that formed from that collapsing cloud, out of all the violence and the loss, out of the tilted planet and the shattered moons and the exiled giants, and the trillion wanderers in the dark, one small rocky world in the calm inner region cooled and steadied, and, in the long quiet after the bombardment, gave rise to something new. It gave rise to life, and then, eventually, to a kind of a life that could look up. That could notice the tilt of a distant planet and wonder what caused it. That could photograph the stitched-together face of a moon and recognize a scar. That could build machines of logic to rerun the birth of the solar system and discover, in the refusal of the math to work, the ghosts of the missing planets. We are the part of this story that can read the other parts. The exiled worlds drift in the dark, cold and alone, and they do not know they are exiled. They cannot know anything, but we can. We are the single place, so far as we know, where all of this violence and loss finally became something that could understand it had happened. The scars are 4 billion years old, and they waited that entire time in silence, and we are the ones who finally came along and read them. So the next time you see that tidy drawing of the solar system, the neat rings and the calm circles, I hope you see it differently. I hope you see it for what it truly is. Not a diagram of how things were meant to be, but a snapshot of what survived. A picture of the calm that a catastrophe left behind, precious precisely because it was never promised. Hold that thought gently as you drift off tonight. The sky above you is quiet. The planets are turning in their patient circles just as the drawing shows, and underneath that quiet lies a history of loss and violence and staggering good fortune, written in scars we have only just learned to read, on a world lucky enough to have someone left to read them. I said at the very beginning that I expected the terror of the title to come from danger, and that the real unease turned out to be something quieter and stranger. Let me name that unease precisely now at the end, because I think it is the true gift of the whole subject. The unsettling thing is not that something is coming for us. Nothing is coming for us, not in any time we need to fear. The unsettling thing is the opposite. It is that the calm we live in was never owed to us, never promised, never part of a plan. It is the leftover of a catastrophe, the arrangement that happened to survive when the violence stopped, and the same physics that made it could, given enough of the time this universe has in abundance, unmake it. To look into the history of our own worlds is to discover that the ground of our security is far thinner and far more accidental than the drawing ever let on. And strangely, once the first chill of that passes, what is left is not fear. What is left is a kind of tenderness toward the calm, precisely because it is not guaranteed. Consider what it took for you to be here, listening to this, drifting towards sleep under a quiet sky. It took a cloud collapsing in the dark and a star igniting at its centre. It took a disk sorting itself into worlds by nothing but distance from the fire. It took a crowd of giant planets holding a fragile balance for hundreds of millions of years and then losing it. It took an extra planet or two taking the hardest blow and carrying it out of the system, jumping Jupiter clear of the inner worlds on its way into exile. It took a bombardment that battered the young Earth and then, mercifully, tapered off. It took a tilted planet and its shattered moons absorbing the violence at close range so that we could later read the story in their scars. Every one of those events could have gone another way, and in most of the ways they could have gone, you are not here. The fact that you are here, warm and safe enough to fall asleep to a story about the end of worlds, is the least likely and most precious outcome of the whole long chaos. So let me leave you where we began, with the drawing, seen now with different eyes. The tidy rings are still there. The planets are still turning in their calm, patient circles exactly as the picture shows. But you know now what the picture leaves out. You know about the older, larger family and the members it lost. You know about the tilt of Uranus and the stitched-together face of Miranda and the craters that clocked the ancient bombardment. You know that 2 worlds as real as this one are out there tonight, cold, dark, and alone, and that their fate could have been ours. And you know, most of all, that the calm above you is a survivor, not a certainty, a reprieve won by violence and luck and paid for by planets we can no longer find. Hold that gently as you drift off. The scars are still here, on the worlds overhead, and in the numbers that will not add up without the missing planets. And we are the ones, on this single lucky world, who finally learned to read them. Rest well. The sky's quiet tonight, and now you know what it took to make it so. Before I let you go, let me offer one gentle correction to the fear the title invites, because I would rather you carry wonder than dread out of this. The word terrifying is the doorway, not the destination. What we found, following the scars down into the past, was not a threat lying in wait, but a truth about how fragile and how fortunate our calm really is. And fragility, properly understood, is not only a source of fear, it is a source of care. We do not treasure things that are guaranteed to last. We treasure things precisely because they might not. The tidy sky above you is one of those things. It came through violence and loss to reach this quiet, and the quiet will not last forever. And both of those facts together are exactly what make it worth looking at closely, worth understanding, worth the 2 hours we have just spent following its history into the dark. The terror, if there ever was any, dissolves into something better on the way back up. It becomes gratitude, the particular gratitude you feel for a calm you now know was never owed to you.